Hi, today I am going to continue with the topic array we were discussing in the last video. So we have seen array, what is this array and how we can store values inside the array in one dimensional or whether it is two dimensional. So now we'll see how to find the addressing of an array elements. Okay, so first take it for the one dimensional array. Suppose this is one dimensional array. So 1D array is imagined as this. Suppose an array indexes start from 0, 1, 2, 3, 4, 5, and so on. Okay. So if you are asked to find the address of any particular element and you are given the base address of this array, suppose this is the array name is ARR and it has maximum size is 10 and your base address is given. Okay, so then suppose it is 2040. Then you are asked to find the address of third element or seventh element, any particular element. Suppose seventh element. The seventh element will have index number 6. So that will be denoted by ARR 6. So in general, if I ask you to find the address of array I, means I plus 1 elements address, array I is the subscript, okay. Element will be I plus 1. So for this we have generalized formula to find the address of particular. So for this you just remember this, that this I array I is the address. It will give you the address of I plus 1 element, because see, I have shown you here the index number 0. It will store the first element, it will store the second element, means the index number is 1 less than the element number. Okay, index number is 1 less than the element number. And sometimes you are given that your array lower bound and upper bound is different. Okay, sometimes you may be given like this, that your array is starting from 12 to 39. So here it is your lower bound and this is your upper bound. Okay, sometimes you may be given like this. So we will see the formula using this generalized formula. And if you are not given any lower bound, that means the array index is starting from 0. Okay, array index is starting from 0. And upper bound is the your size minus 1. Okay, now you are asked to find the address of array I. It means the address of which element? Element I plus 1. Okay, so we'll have this formula of this address of array I will be equal to base address plus I minus lower bound into your size of each element. Okay, What is this LB? LB is your lower bound. So if suppose, for example, suppose you are given this array, starting address, starting element is 21, and it is going to 200. Suppose starting addresses, starting index is 21 to 200, and your base address is given as 2040, and it is said that it is storing integer type of values. So the size it will require for each element is 4 byte. 4 byte for each. Now we have to find the address of, suppose I ask you to find the address of array 70. Okay, so I is now here 70. So how you will find the address? Address of array, we'll write ARR, the name of array. '70 will be base address plus I minus lower bound. Here you are given the lower bound as 21. So we'll write 2040, the base address of the first element. I is 70 minus lower bound is 21 into size is 4 byte. So what will be the answer? 2040, 70 minus 21, 49 into 4, 2040. Okay, so we'll add this. 2236. So the address for this array 70 will be 2236. So this is for one dimensional array. And suppose I ask you and change this, the array lower bound is starting from 0. In this question, if I modify this question, that array lower bound is not given to you. Okay. It is simply asked that you have to find the address of array 70 and the base address is given. Base address is given 2040. In that case, what you will do? You will just have to find the base address plus I minus lower bound will be 0. So that will become 70 only. 70 minus 0 into size of each element is 4 byte. So it is 2040 plus 280. So it will be 0, 2320. When lower bound is not given. Not given, we assume it as 0. So now we'll see how to find the addressing in 2D array. So suppose you are asked to find the address of array ij, ith row and jth column index. So suppose that you want to find the address of array I j. We have seen for the ith, for one dimensional we have seen, and suppose for two dimensional array you are supposed to find the address of array ij. So for this, suppose we have base address BA is base address, size S is size of each element, size of an element, and then I is the row subscript, of the element, whose address is to be found, whose address to be found. J is the column subscript of the element whose address to be found is to be found. And suppose your array has lower bound and upper bound given. So we say that LR is the lower limit of row, or you can say starting of the row index, and similarly lower lower column means lower limit of column, or you can say the starting of column given of the given matrix. Okay. So we need to use this. Suppose in a two-dimensional array you are given like this. Suppose array has lower count, lower row and upper row, and then lower column to upper column. So we need to use this LR and LC in our formula. That's why I am writing here. So address of ij array ij will be base address plus I minus LR, the lower limit of your row, into the number of columns given in your matrix plus J minus LC. LC is the lower limit of your column given for the matrix. So in this way you can find out the address of ith array ijth element. So why I am saying this? See, why I have multiplied with this n. N is the number of column. Suppose your matrix is m cross n order. M cross n order. So m is the number of rows and n is the number of column. M is number of rows and n is number of columns. So in your, just wait. Row measure order, the every row is first completed for all the, suppose we are reading this 0th row, so it will fill all the columns first, 0, 2, 3, 9, 2, 3, 9. So it has 3 columns. So it will fill all these 3. Then it will come to second row. It will fill all these 3. Then it will go to the third row. Suppose it has third row, then it will fill all the 3 columns. Suppose we are here. So it will fill this rows all column, this rows all column. That is why it is multiplied with the number of columns here in the that particular row. All the columns element will be filled until, and in the last row in which we are going to find the address, in that till jth all the elements will be filled. So in this way we can reach to the that particular element ij, and we can find the address of that element in row major order. This is row major order. Now come to column major order. So in case of column major order, when we go to the first column, suppose this is the first column, it will fill all the rows. Then second, it will fill all the rows. And then particular, suppose we want to find the address of this particular element. So it will fill this element and then this will go to this. So here we will multiply with number of rows. Okay. So now we'll see what is the formula for this. Address of array ij will be the base address plus I minus LR. Let's wait. LR. Okay. So we can write this later on also. J minus LC. We are subtracting this J minus LC into M. Or we have not multiplied here with the size of each element. Okay, we have to multiply that also into the size was S. So here also we will multiply into the size. So here see the difference between both of them, row major order, column major order. We are doing J minus LC here, J minus LC here also. But in this case, column major order, we are multiplying with this column part, M, the number of rows. And here we are multiplying with in the row part with number of columns. M cross N was the, see, you can think of this as small m. Okay. So if I say that your matrix is M cross N order, so M, small m is here and here it is small n. It is multiplied with the row part and here it is multiplied with the column part. So if you are given some lower limit, upper row and lower column and upper column, then you will use this. Otherwise, the default value is 0. So suppose you are given that array has this index. So you can use this formula to find the address of any particular element of this two-dimensional array. So let's take the some example so that you can understand it better. Suppose you are given this array 1 to 20 and this is 1 to 90. So here it is given 1 to 20 and 1 to 90. If you are not given this part, this one, suppose you are just given like this, array 20, 90. So it means the lower limit will start from 0 to, it will go to till 19, it will go to 0 to 89. And otherwise it is given like this, it means it is starting from 1 to 20 and going column starting from 1 to 90 going to. Okay. So we'll use this formula defined for row measure order and column measure order. See. So we'll see for one, suppose the size of each element is 2 byte or 1 byte. Suppose you are given that it is the size of each element is 2 byte. Let's say 2 byte. And your base address is given as 1040. Suppose. Then the address of, you have to find the address of 5, 5. No. I is 5, J is 5. So what will be the formula for row measure order? Base address. You have seen here base address plus I minus LR into N. I minus LR into N plus J minus LC whole into size. And what is the M cross N? Number of rows is 20. M cross N. Number of rows is 20 and number of column is 90. 20 into 90. So N is 90. So base address given is 1040 plus I. I is 5 minus LR. LR is 1 into N is 90. J is again 5 and lower limit of column is 1 whole into size. 1040 and now 5 minus 1 is 4 into 90 is 360 plus 5 minus 4. 5 minus 1 is 4 into 5. 1040 plus 364 into 5. So this is 1040. One eight two zero. Now add them. 6. This is 8. And this is 2860. So this will be the address of array 55. So similarly, you can find for column measure order also. So this is, you have seen two-dimensional array. We can have three-dimensional array also and other higher dimensional array also. So for three-dimensional array, we will have three subscript like array, three-dimensional array, array I, J, K. We will have three subscript and we can use all three to find the elements, or to access the elements we can use this three subscript. Okay, so let's see. For this, we will suppose we want to enter elements in this three-dimensional array. For what we have to use, we have to use three loops. For I equal to 0, I less than, suppose we have M, N, and P. The higher values of row, column, and this third one is for the third dimension. Okay, so I equal to 0, I less than M, I plus plus. Then for j equal to 0, j less than n, j plus plus. And for k is equal to 0, k less than p, k plus plus. And then we'll use scanner. Suppose we want to input, we'll write %d, and here ampersand array I, j, k. So we'll use 3 subscript to find this. And similarly, we can print the elements of this array using these 3 for loops. So that's all for today. Thank you. Thanks for watching.